In this video, let's take a look at the power of 2 algorithm. Here is a problem statement. Given a positive integer n, determine if the number is a power of 2 or not. An integer is a power of 2 if there exists an integer x such that n is equal to 2 power x. For example, is power of 2 of 1 returns true since it is equal to 2 power 0. Similarly, is power of 2 also returns true since it is equal to 2 power 1. Is power of 2 of 5 on the other hand returns false since we can't find an integer x that satisfies the equality. If you've understood the problem, please pause the video and try to solve the problem. Alright, let's now solve the problem together. Before we write the code, let's understand how should we go about this in pseudocode. Let's take n is equal to 8 as an example. What we are going to do is repeatedly divide 8 by 2. So 4, then 2, and then 1. At each step we check if the remainder is 0. If at all the remainder is non-zero, we can return false and safely say it is not a power of 2. If the division continues and the number comes down to 1, we say it is a power of 2. If you have understood this, let's write the code. Let's begin by defining the function in VS Code. Friends, before I continue, I would like to remind you that it's important that you like this video and subscribe to the channel. Those YouTube algorithms will promote my video and more people will watch it. It would be great. So, function is power of 2, parentheses, curly braces. The function will have one parameter n, which represents the positive integer for which we need to run the is power of 2 test. For example, calling the function with n equal to 1, 2, and 5 should return true, and false respectively. Now, what we do know from our problem statement? We know that n is a positive integer, so let's begin by adding an if condition. If n is less than 1, return false. Next, we add a while loop. The loop should run as long as n is greater than 1. So the condition is n greater than 1. Within the loop we check if the remainder when dividing n by 2 is not equal to 0. So if n modulus 2 is not equal to 0, return false. Otherwise we divide n by 2 and repeat the loop. So n is equal to n divided by 2. After exiting the loop, it can only mean that n is equal to 1, and the remainder has always been 0. In that case, the number is a power of 2, and we return true. That is pretty much the code needed to verify if n is a power of 2. If I run the code, we see the true values corresponding to each function call: true, true, and false. Our code works as expected, and you probably know what's coming. I would like you to take a pen and paper and trace the function execution for n is equal to 8 and n is equal to 5. That will give you a more clear understanding of the code we have written. Alright, it is time to determine the big O of our is power of 2 function. Pause for a minute and determine the big O. Here is a cheat sheet which can be used as a guide. Pause now, or let's estimate the big O together. A function contains one while loop. From our cheat sheet you might think that the big O is linear time complexity. However, this is a while loop and you need to pay attention to how n is changed within the loop body. In each iteration we are reducing the value of n by half. If we take a look at our big O guide, this satisfies the fourth statement. So the time complexity is actually O of log n. The number of instruction executions increases as n grows, but not by the same amount. So big O is equal to O of log n. Now what we have here is a good solution. However, there does exist a solution which of the constant time complexity. It's one linear, so we will have to understand with an example. The solution involves the use of bitwise operations. Let's call the function is power of 2 bitwise parentheses and curly braces. The function accepts n as a parameter, and within the function body we still check if n is less than 1. If it is, we return false. However, to check if n is a power of 2, we return n, bitwise and operator n minus 1. We compare this with 0. If this is a 0 and is indeed a power of 2. Simple, isn't it? Well, let's understand the magic behind the logic. In binary, a number that is a power of 2 except for 1 ends with a 0. Here is a small list of such numbers: 1, 2 in binary, 3 in binary, and 4 in binary. If we try the bitwise and operator with the previous number, you can see that we always end up with a 0. To help you jot your memory of JavaScript operations, bitwise and is 1 if both numbers are 1. Else it is a 0. You can see for all powers of 2 and 1 bitwise operation which the previous number will return 0. So if we run the code with is power of 2 bitwise, we still see the same output: true, true and false. The solution, however, is more optimal. The time complexity, like I mentioned it already, is constant, O of 1. Irrespective of how large n is, we only have to run this line of code once. This is the best solution you can find of the power of 2 algorithm. Alright, with that we have completed the 4 math algorithm we set out to solve in this section. Now it's time to learn about a very important concept called recursion. If you're a computer science engineer, this might be more of a recollection. For the others, let's understand what is a recursion in the next video.